I have, so like that, P1x, we got something, P2x, I don't need to write again, okay? So this one up to, if you find the nth derivative, so all the terms are one by one, it is cancelling. So at last you may have n into n minus 1, n minus 2, up to 2, 3, 2, 1, a naught. As well as here, x minus x naught to the power of 0. That's I said this will be, anything power of 0 will be 1. Isn't it? So we don't need to write. Okay. So this is what n into n minus 1 up to 3, 2, 1. It is a n factorial. Okay. With the coefficient an. Sorry, this is an. Okay. So this is our output of p and x. But still we are not finished. Okay. So they asked to, asked to give the answer in terms of y naught, y1 dash, y2 dash, like that. So as I said, we have px naught, we are taking as y naught. So what is px naught? Okay, I will erase this one. I'll write again. Okay. So at x equal to x naught, what is px naught? This is equal to y naught. What is this one? If you substitute in our main equation 1 as x equal to x naught, what you'll get? Similarly, p dash x naught, which we call as y naught of 1, which called as what? So substitute x naught at the p dash x. Okay. Similarly, p double dash x, or you can give 1, this one 2. Okay, x naught. So what is that? Y naught 2. Similarly, p n x naught, which is equal to y naught of n. So can you fill these spaces? So substitute x equal to x naught for this on these equations we have derived already. So what will be the answer? So still the asked people are not answered to me. Okay. So I asked the person 26, which, what else? So 35, 151, 159 or something. Okay, can these people prove your attendance, or otherwise you will be as absentees by sending the answers? What is 0? For what 0? I don't understand. Is a px not is equal to 0? If you put x equal to x naught in the function and the equation of 1, are you getting 0? You check your answer. No. Your first two answers are correct, 144. Other two are wrong. Check your answers. 77 also. First two answer only correct. Check the next one. So you should have, yeah, correct. Sorry, your answers are correct. This will be A naught, no? Yeah, sorry. So this will be, yeah, A1. So if you do P2, you get 2A2, no? Yeah, correct. So if it is Pn x naught, it will be n factorial time An. Okay, that's how your answer should be. So you can see our coefficient of A naught will be y naught. A1 will be y naught 1. A2 will be what? From this A2 will be y naught of 2 divided by 2, no? So what is this one? An will be y naught n divided by n factorial. You can write 2 as 2 factorial also. Okay. So why we are doing is we are finding ones. What is that 0? Can you explain? 0, 5, 1. 151 and 159 are sending me just like answer 0. I don't know what it is. Can you tell me? Can you elaborate what your meaning of 0? I don't understand. You're just sending one answer 0. I don't understand what is that your answer. You just pretending you are answering. Is that? Okay, let me continue the answers. I don't want to spend much time here. So at last, therefore, solving for the an coefficients and substituting, we get, okay, now we have found the relation of the coefficient a0, a1, a2 up to an. Okay, a0, a1, a2 up to an in terms of the y0. Okay, so we're going to substitute that, which is equal to, so a0 is equal to y0. Okay, a1 is equal to, okay, y0 1 plus, sorry, x minus x0, no, yeah, plus what about this one? For a2, you have to have y0 2 divided by 2, no, it's like a 2 factorial, it's like 1 factorial. Okay, x minus x0 the power 2, just like, which is equal to y0 of n divided by n factor, because an is equal to y0 n over n factorial, x minus x0 to the power of n. Okay, we got the idea. Now we can write this as a common, no, everything are common. So for the 1, I put 1 factorial. For the 2, I put 2 factorial. Why? 2 factorial is equal to 2 times 1, no, which is equal to 2. So because to get the one nice formula, I put like that. Okay. So which I can write. So how I can write? From this, I can write a common equation, no, which is equal to 1 over n factorial. So write down y naught of n. Okay. Sorry, I can write I factorial. This will be I factorial. Therefore, I is equal to 0 up to 1 n. Okay. So I'll write again. The summation I is equal to 0 to n 1 over I factorial. Okay, I factorial. So this I can write y naught of I. Okay, this will be x minus x naught to the power of I. Okay, so I can write this as a common term of this one. Is that correct? So this will be the answer for this question. Okay, let's continue our notes. So that's all about the polynomial of our chapter number 2. Okay, so we have finished the section 1 for the chapter number 2. As well as we are having in this syllabus, you can see in the chapter 1 we have seen, wait, as like chapter 1 we have seen section 1 as a number system and errors, section 2 as solution of equal one variable. Similarly, chapter 2 we have seen the polynomials. Okay, so we have finished polynomial. Now we're gonna see the linear difference equation of first and second order. Okay, so that is our second target. So after that we can continue our next sections. So yeah, let me continue the things. Okay, our section 2, which is for linear difference equations. It's not a differential, okay? It's a difference equation. We call it as difference. Difference means the difference between two elements, like that, okay? So linear difference equations of first as well as the second order. So that is our section number 2, chapter 2. This is our section 2. So put the heading finite differences. So finite differences means, so it's like finite, infinite. Finite means it can be countable, isn't it? So in that sense, we're going to see some methods of difference, okay? So let's see. So write down the note under the finite difference. So there are two kind of difference we're going to see, okay? For a discrete function, so functions of discrete, it has discrete means discrete as well as continuous, two opposite functions, okay? Discrete means we can find the value for each point, each discrete points, okay? Continuous means it goes like that, okay? So it has the interval, this to this, this to this, like that, okay? There are discrete. So for a discrete function, a finite set of argument xk for each having a mate yk. It means for the xk, the value will be yk. For example, y is a function of x, okay? So f of x equal to yx. So according to the x changes, x naught is equal to y of x naught. This is one of the value. Let's say y naught. So f x equal to x1. So y x1. So according to some discrete values, okay, this function has x value, xk values and yk values, okay? And supposing the argument equally spaced, okay? So we're gonna find this function to this, let's say this x0, this is x1, this is x2. It goes like that up to xn. Also, we are having these differences between the points are equally divided, okay, equally spaced. So that space we are taking as h, okay? It means the biggest, let's say this will be x2, no? Let's say k is equal to 2. So what is the difference? H is equal to this difference, no? So x2 minus, can you mute your mic, please? So x2 minus x1, okay? So this will be h. Similarly, you can for x4 minus x3, which is also h, okay? So equally, each points are equally spaced, okay? So that's what it says. Between the consecutive points, the difference is h, okay? The differences of the yk values are denoted, okay? So, okay, give me a second. What that it says is, between the point of x value, I have taken the discrete point with some equal space points, okay? On that you may have a function value, no? Let's say this is my function. Okay, give me a second. My drawing has some issues. Okay, let's say my function is this way, okay? So in this, we have this one. In this, we have this one. In this, we have this one. So these are functional value. Let's say this is my y naught. If it is x naught, this is y naught. This is x1. This will be y1. This will be x2, y2. It's like that, okay? So this will be the xk plus 1 minus xk is the h. Values is h for the x values, okay? But if you wanted to find the difference between these two, okay, like this, for example, let's say this is my x1, this is x2, so this is my h, but the functional value will be like this, no? So like this. So I need to find, so delta yk will be, this is my y2, This is my y1. So like that, delta yk, I said yk plus 1 minus yk. So if you taking this way, we called as a forward differences. It means it's go like this, forwarding to the next, okay? But see the notation also. We use the forward difference, this delta, okay? This delta, okay? If it is this point is here, we called forward. This point is here, we called as backward, okay? Backward means from this to this, like y. How I supposed to say? So if I say delta, let's say delta yk, which is equal to y2 minus y1. So this is the point, the next point, okay? Next point of let's say y1. If it is y1, I need to take the y2 minus y1, okay? Other point, the next point minus this point, okay? But if it is this backward, you have to take the same yk from the less than that yk, okay? Yk minus. So it is backwarding this way, okay? So it is called as the backward difference. So that is the notes here, okay? So you can write down. So these are called our first differences, okay? So we're gonna see our first and second order now. So first is defined in this way. So you can easily keep mind, okay? If it is yk, you have to start with yk plus 1 consecutive more than 1, more than k, then separate by this yk. But if it is backward yk, you have to use the same yk minus 1 less than that one, okay? So this is what we call as the backward. So these are the first differences of these discrete functions, okay? Okay, let's continue. Next one, let's define the second differences in the same way from the first. So as you know, we can define the delta yk first one, or this yk backward. From this only we're gonna define our delta squared yk. That is we called as a second differences, or this one gradient, this one, okay? So we have to use the difference of these first differences are called the second difference. So let's say my delta yk is equal to what? Y of k plus 1 minus yk now. So if you wanted to have delta squared yk, if you wanted to have the difference of difference, so you have to have delta of yk plus 1 minus delta of yk. So difference of difference we called as the second difference. Okay, difference of first difference we called as the second difference, not the differential equation. Okay, this is different from the differential. Okay, this is a different case. This is just finding the subtraction between the consecutive points. Okay, so what do you think? So this one yk plus 1 is what? Please, delta yk is yk plus 1 minus yk. What is yk plus 1? You have to substitute wherever k is k plus 1 now. So can you tell me what is this one? This one already know. Yk plus 1 minus yk. So what is this one? And can you find the final answer? So final answer should be this one. Can you check? So far some students are not answering. So 26 and 35 I'm taking as absentees. Okay. correct. 77 and 144 correct. So just to substitute, no? That's not a big thing. So if it is delta of yk means, so now you know what is delta yk. So go back to the polynomial functions, and whenever you find this one, it calls this one, okay? I'm coming, so you can use this idea there also. It means yk plus 1 minus y of k. So delta squared yk means delta of yk, okay? It's like what? Delta of, for the yk, what you can say? Yk plus 1 minus yk. So I can take this delta inside. Okay, that's how it comes. So I know this one will be minus yk plus 1 minus yk. So if you substitute same for k plus 1, you have what? K plus, for k plus 1, no? So k plus 1, 1 extra. It's like k plus 2 minus same, no? Same yk. You are subtracting k plus 1. So what is the final answer? Y of k plus 2. This is minus yk plus 1 minus yk plus. So 2 times yk plus 1. Minus into minus plus yk. Okay. Yeah. Check your answers. So as you know, the second difference is difference of first difference. Okay. First difference. So be careful on your wording. That is differential. Differential. So it's not we are talking about. This is difference. It's like a subtraction between the near point. Okay, that's all. Okay, so see this one. Delta yk is equal to yk plus 1 minus yk. Delta squared yk is equal to yk plus 1 y of k plus 2 minus 2k plus 1 plus yk. So is that possible for you to find the nth general one? So I'm erasing this one. So generally, in general, it is like delta n of yk. So n times we are taking difference means it's like this one, no? Delta into delta n minus 1 yk. Okay. So as I said, you can take this one. Wait. Sorry. This is n minus 1. This is delta. Okay. So when you add n minus 1 plus 1, it will be n. So this will be n minus 1 times. We know this one, no? This will be yk plus 1 minus y of k. So if you include like a bracket cancellation, this is like a minus delta n minus 1 y of k. So what is this one? It's like a, so nth difference will be difference of n minus 1's difference. Okay. So this is we call the nth difference. Nth differences. Okay. Okay. Do this do as a homework. Okay. Exercise. Find the answer for delta cube y naught is 1. Okay. Similarly, delta 4 y naught. So this is y naught. Okay. So find the answer for this one also. So as you know, delta y naught will be what? Can you answer me this one? Okay. So delta yk will be yk plus 1 minus yk. So wherever k you put y naught, no? This will be y1 minus y naught. That's all. Okay. So according to that, you find it. Okay. So before that, I wanted to teach you some more things as well. So we have, I think 10 minutes, less than 10 minutes. Okay. So this is what I told you. Okay. In general, this one. So let me try this example. First of all, let's, okay. Similarly, after you find delta, okay, give me a second. Okay, after you find delta y naught, delta squared y naught, delta cube y naught, delta 4 y naught, find the possible general idea of the n y naught. Okay, using the summation. Using the summation, you find the answer. Okay, that is your homework. Okay, so I'm gonna show you one method how we can use this idea using some tables. Okay, so write down the homework. So you can find, yes, correct. Everyone are correct. So find homework for the yn delta n of y naught. Okay. Okay, this is called as a. So can you mute? Somebody has been in the unmute. I don't know who. 089. Yeah. Okay. So this is we called as a. As you know, you can read if you are like. This forward backward difference is a concept of Isaac Newton. Okay. He is the one find these things. So Newton's forward difference, Newton backward difference also another name for these ones. Okay, so that's that for extra thing. Okay, so our meeting also going to be finished within 10 minutes, so not a problem. So let's you don't need to draw now. Okay, I will send you the notes anyway. Just see the idea. Okay, so how we do this one. If they ask you to solve the one question using forward difference table or backward difference table, this is how you have to put. Okay, first of all, you put the x values, x, x0, x1, x2, x3, x4. Let's say x0 is equal to 0, 1, 2, 3, 4. Let's say like that. Okay, let's say my y is equal to x square. Okay, this is my function. So what will be this one? Y naught will be, if you put 0, it will be 0. If it is 1, it will be 1. It is 2, 4. Just like that. Okay. 3, 9, 4, 16. Like that. Then what is, then y is equal to fx. Then delta f. This is how you have to create the table first of all. They won't give you. You have to create x. Y is equal to fx. Then delta fx, delta squared fx, delta 3 fx, delta 4 fx. You can go anywhere. They may say until 5th difference, 6th difference, like that. Okay. So when you see this one, how to find the delta fx? It means delta yk, which is equal to k plus 1 minus k naught no, yk. So these are the value. So if it is delta y naught, what is that? Y1 minus y naught no. So rather than this one, see, you have to find the difference of this minus this. Okay, did you get that? So y1 minus y0. So what will be the answer? 1 minus 0 will be, for this example, my answer will be, sorry, 1. Okay. So what is the answer for this one? 4 minus delta y1 will be 4 minus 1 will be 3. 9 minus 4 will be 5. Similar wise. Okay. 60 minus 4 is that 7? Okay. Then the second derivative. So 3 minus 1 will be, so you have to put a blank for other terms. Okay. So y2 will be 3 minus 1 will be 2. 5 minus 3 will be 2. 7 minus 5 will be 2. So you will get some point where this is coming to reaching 0. So this will be what? 2 minus 2, 0. 2 minus 2, 0. So you don't have delta 4 for my example. But there are some examples which you have to go further. Okay. So this is we called as a forward difference table. Okay. So I will send anyway. So according to the question, you can do this. Okay, I will send the question as well. Similarly, let's go back to the backward also, so I can finish up. Okay. So similar way, backward also working on that same way, but we know what is that? What is delta yk? Backward gradient yk will be yk minus 1. No? So you should have other one, earlier one. So you have to come from here to here, here to here, here to here, here to here. So you can see how it is. Okay. The same concept. Even though if you do the forward, it is equal to the backward. Okay. So no any differences anyway. So this is what we called as the tables, forward difference table as well as backward difference table. So we have only 258. So I'm gonna finish lecture, but I will send some example as well as this one we can I'll send the notes. You just go through the some some property of difference formula. It means what? For example, this one is, if you are taking the difference for a constant value, it should be 0. Okay, because we don't know, it's for variable. No, yk is a variable. For 0, we don't know, c minus c will be 0. Okay, that's fine. C is a constant. Similarly, if you have a constant time another, let's say delta time 2 times delta uk or something. So you can take the 2 outside, just like this one. Okay. So that other one, if you are adding, you can add like, that's what I told you already. Okay. You can put the delta, cancel the bracket. So I'm going a little faster because I can send you these notes. It's not that big deal. The point you have to keep in mind is this one. Okay, go through this product and division. Okay, these are the point you have to be careful. Okay, so you can see just like UV form. Okay, UK VK. Let's say we have 2. If you want to take the multiplication, what do you do? UK times VK. No. Again, you will think VK into delta UK. But here, just a simple difference, you have to have the K plus 1. Okay, that's the only difference here. Similarly, this also like a delta U over V form. Okay, U over V form. But only thing is here we take V squared, VK squared, no. But here, VK plus 1 into VK. That's a small difference. Okay, this is what you have to keep in mind. Also, you find that in the book, there's a proof for this. So I will finish here. I will send this. You can check. Okay. So I've finished now the lecture. Thank you.